So this project focused on building a steady hand minigame as an interactive tool to help students understand the basic electrical circuit principles. So this main idea is to show how open and closed circuit works, how conductivity allows current to flow, and what happens when a circuit is completed. So this game uses a twisted copper wire track connected in series with a power source and a buzzer. So players will move a metal loop along the track without touching it. If the loop touches the wire, the circuit closes, the buzzer activates, and this gives instant feedback that an error has been made. To create this game, we designed the layout, assembled the wooden base, fixed the metal rods, connected the wiring, and tested the circuit to make sure it worked properly. In the end, the steady hand game works as a simple but effective prototype. It clearly demonstrates how electrical flow behaves in a circuit, and it provides a fun, hands-on way to students to learn and visualize this basic electrical concept.
Understanding basic electric circuit is an important foundation in physics education. Students are often introduced to concepts such as open and closed circuits, conductivity and current flow through textbook, diagrams and theoretical explanations. However, these ideas can be abstract, and many learners struggle to visualize how a circuit actually works in real life. Hands-on activities and educational games have been shown to greatly improve comprehensions by allowing students to interact directly with the concept they are learning. Like this, many traditional teaching methods do not provide immediate practical demonstration of how circuits function. Without an engaging learning tool, students may find it difficult to connect theory with real-world applications, and this can limit their understanding. Therefore, there is a need for a simple, cost-effective and interactive aid that can help students experience the basic principle of electric circuits in an enjoyable and meaningful way. To address this issue, our project focuses on developing a steady hand mini-game that visually and audibly demonstrates circuits completion. The objectives of the projects are to design and construct a functional steady hand game prototype to demonstrate the principles of open and closed circuits through interactive gameplay, and to provide an engaging educational tool that gives immediate feedback through a buzzer sound whenever the circuit is complete. This introduction set the stage for understanding how our mini-game serves as both a learning aid and enjoyable hands-on activity for students studying electric circuits.
So for the materials or instruments, the materials used for this project included a wooden board which is 20 x 30 cm in size, 2 metal rods, insulated copper wire, a 9-volt battery, a 9-volt battery connector, a piezoelectric buzzer, a roller, electrical tape, as well as the basic soldering equipment. As for the procedure, the wooden board was prepared to serve as the base of the mini-game. 2 metal rods were mounted vertically at opposite ends of the board. A length of copper wire was stripped of its insulation and shaped into a challenging, non-uniform path. The ends of this wire were securely attached to the 2 metal rods. Next, the electrical circuit was assembled by connecting one terminal of the buzzer to one of the metal rods. The remaining terminal of the buzzer was then connected to the positive terminal of the 9-volt battery. The negative terminal of the 9-volt battery was connected to the second metal rods, completing the main circuit. A handheld tool was created by attaching a loop of bare copper wire to one end of a ruler using the electrical tape. This loop was connected via a wire to a junction between the buzzer and the battery, placing it in like a series. When the loop touches the shaped copper wire track, the circuit closes and the buzzer will ring it. The entire setup was tested to ensure proper continuity and safe operation. Lastly,
the steady hand game successfully demonstrated how open and closed circuits work. During testing, the buzzer stayed off when the metal loop did not touch the wire and activate immediately when contact was made. This confirms that the circuit functions as designed. Compared to similar educational prototypes, our game includes a more challenging wire path, which improves hand control skills and makes the activity more engaging for learning. Some limitations were observed. The buzzer's performance depended on battery strength, and the copper wire could bend if not secured firmly. However, the prototype still worked consistently across repeated trials. The game also connects to physics concepts like force and motion, as players must control their movement and apply steady force to avoid touching the wire. Overall, the project effectively served as an interactive learning tool for basic electrical circuits. Some limitations were observed. The buzzer's performance depended on battery strength, and the copper wire could bend if not secured firmly. However, the prototype still worked consistently across repeated trials. The game also connects to physics concepts like force and motion, as players must control their movement and apply steady force to avoid touching the wire. Overall, the project effectively served as an interactive learning tool for basic electrical circuits.
In conclusion, this project successfully created a steady hand minigame that demonstrates how open and closed circuits work. The buzzer gave immediate sound feedback when the loop touched the wire, proving that the circuit functioned correctly. The game also showed the concept of force and motion, as players needed steady and controlled hand movement to avoid completing the circuit. Overall, the steady hand game is an effective, low-cost tool for learning basic electricity and improving fine motor skills.
We would like to express our sincere gratitude to everyone who contributed to the successful completion of our Steady Hand Game project. Special thanks to our lecturer, Dr. Umair bin Abdul Halim, for the guidance, feedback and support throughout the development process. We also appreciate our teammates, especially Ashraf Ameen, for being a great team leader to ensure the completion of the Apex 2035 project. Other than that, we also appreciate the other fellow teammates for their cooperation, commitment and teamwork in designing, building and testing the game. Lastly, we are grateful to all individuals who provided suggestions, resources or assistance that help improve our project.